Welcome, traveler. You've chosen to spend the next hour of your life listening to someone whisper sarcastically about rocks and gas clouds. Good call. Let's begin. So, let's rewind the cosmic clock to about 4.68 billion years ago. That's right, before your precious Earth was even a twinkle in the galaxy's eye. Back then, this part of the Milky Way was basically a giant galactic landfill, a swirling mess of hydrogen, helium, microscopic dust, and the shattered leftovers of ancient, overdramatic stars that exploded themselves into oblivion. Everything smelled vaguely like plasma and regret. This was the solar nebula, a fancy term for a floating cloud of cosmic trash. And like all good trash, it eventually attracted attention. Gravity, being the nosy busybody it is, started poking around. "Hey," it said, "what if I mashed all this together and made something chaotic?" And so, with the kind of patience only the universe has, things started to collapse inward, slowly, painfully. Like the world's worst group project, clumps of gas and dust began sticking together, mostly because they couldn't figure out how to escape. Collisions happened. Debris got hot. Everything spun faster and faster, like a toddler on a sugar bender in a swivel chair. At the center of this cosmic blender, a proto-sun was forming. That's right. Your local star, the one responsible for all your sunburns and failed picnics, was still just a dense, glowing baby ball of fusion frustration. It hadn't even turned on yet, just sat there, judging the mess around it like, ugh, I guess I have to light up now? Meanwhile, farther out in the swirling disk of chaos, things were bumping and clumping. Tiny particles turned into pebbles. Pebbles became boulders. Boulders started throwing punches, and eventually, over millions of years, and I mean millions, some of these rock piles got big enough to start calling themselves planetesimals. Cute, right? One of them, somewhere in the back of the nebula, was already being a little dramatic. It was hoarding iron, growing lopsided, and occasionally flinging smaller objects off its surface like, "Get off me, peasant." This little overachiever, still nameless, would one day become the stage for all your weird human nonsense. But for now, it was just another hot, rocky brat in a sea of rocky brats. Let's not get ahead of ourselves, though. We've barely hit 4.63 billion years ago, and Earth doesn't even technically exist yet. What does exist? Violence. Endless, unrelenting space rock violence. Everything is colliding, everything is melting. There is no peace, no vibes, only friction. Planetary formation is basically bumper cars with consequences. But wait, there's more. As our proto-Earth-to-be gathers mass, it starts heating up. Internally. Not emotionally. Yet. All that kinetic energy from collisions, it turns this baby planet into a bubbling sphere of molten doom. Imagine lava soup with a dash of radioactive spice. No crust, no water, no atmosphere. Just a big, angry space meatball. And somewhere out there, a smaller rogue object is doing its own thing, unaware it's on a collision course that will define the next few billion years of your precious rock's destiny. But let's not rush to the moon yet. Anyway, at this point, Earth, still not officially Earth, is roughly the size of Mars. Not bad, still growing, still hot, still radiating do not touch energy, and still surrounded by a debris field of cosmic junk waiting to either join the party or get obliterated. Meanwhile, the proto-sun finally kicks on. Fusion ignites. Boom. Solar wind blasts across the system like a toddler with a leaf blower, pushing the lighter gases outward and letting the rocky inner planets know that yes, it's time to grow up or be flung into oblivion. And our little molten meatball, it survives. Barely. So, what have we accomplished in the first 40 million years of planetary pre-gaming? We've turned space trash into a lumpy magma orb that doesn't even have a name yet. A+ progress. So now we have this scalding hot protoplanet, still emotionally unavailable and absolutely unfit for visitors. If you tried to land on it, you'd immediately become part of the magma soup. Congratulations, you're iron now. Hope you like slowly sinking toward the core for the next few millennia. This is the phase where Earth, still nameless and definitely not photogenic, is undergoing what's called differentiation. That's a fancy word for stuff sorting itself out, which humans seem to only manage when forced by gravity or lawsuits. The heavier elements, iron, nickel, gilt, sink down into the center. Lighter elements, silicates, dilution, volcanic gas, float up toward the surface. It's a geological version of high school cafeteria cliques. Metals get all hot and broody at the core, while oxygen and silicon take their drama to the crust zone. A literal inner circle forms, complete with a liquid outer core and a mostly solid mantle just trying to mind its business. Anyway, everything is still on fire. Surface temps? Thousands of degrees. Atmosphere? Not really. It's more like a constant burp of volcanic gases. Hydrogen, carbon monoxide, ammonia. If you tried to breathe it, your lungs would file for bankruptcy. Now here's where it gets spicy. Because about 4.5 billion years ago, our young Earth gets clocked. Like, hard. By an object roughly the size of Mars. Scientists call it Theia, which is adorable for something that basically committed planetary assault. This was not a fender bender. This was full-on cosmic vehicular manslaughter. The impact melted both bodies on contact. A ridiculous amount of material was ejected into orbit. Lava geysers, iron vapor, molten regret. And from that orbiting debris, something round and moody began to form. Yes, your moody neighbor, the moon. So now Earth's got a satellite, but also a massive hangover from the impact. The entire surface was reset. Crust? Gone. Life? Please. Atmosphere? Torched. But the core? Still kicking. That inner iron blob started spinning like it had something to prove, and in doing so, gave Earth a magnetic field. Kind of like wrapping itself in a planetary security blanket. Adorable, but also essential if you don't want to be stripped naked by solar wind every 5 minutes. Meanwhile, the molten surface starts cooling, slowly, like glacially slow, but without glaciers because we're still boiling. Magma begins to crust over. It's thin, fragile, and constantly getting punched by leftover space junk. Think of it as Earth's first attempt at skin. Acne-prone, explosive, a little flaky. Also around this time, volcanoes begin barfing out gas in bulk. Carbon dioxide, sulfur dioxide, methane. It's the kind of vibe you'd expect from a chemical weapons testing facility, not a future home for frogs and brunch. But hey, progress. And now for everyone's favorite topic, water. Where did it come from? No one agrees. Some say it was baked into the minerals already on Earth. Others think it was delivered by comets or water-rich asteroids, like interstellar Uber Eats with terrible delivery times and a habit of wiping out everything in their path. Either way, over the next several million years, water vapor begins to condense. Yes, we're still in that millions of years per sentence part of the script. Clouds form, rain falls, not politely either. We're talking relentless downpours that lasted for centuries. The entire planet is basically getting pressure washed. And eventually, oceans. Not cute blue vacation brochures yet. More like steaming, acidic chemical broths that could dissolve your bones faster than Twitter dissolves attention spans. But still, oceans. Shallow ones, full of dissolved metals and ambition. They slosh around on the scabby crust, like a teenager trying on adulthood, unsure of what's next, but feeling dramatic about it anyway. By now, Earth has calmed slightly. It's still volcanically hyperactive. It still gets smacked by space rocks now and then, but it's mostly managed to hold itself together, sort of. A crust is forming. Oceans exist. The moon is orbiting silently like a judgmental roommate. And deep, deep in the soup, chemistry is getting experimental. But don't get excited, no life yet. Just lots of angry molecules smashing into each other and occasionally forming chains that might someday possibly start behaving like something alive. But that's like 20 episodes from now. Right now, we're still just a barely cooled meatball in a sea of gas and drama, trying to figure out what kind of planet we want to be. Ah. So here we are, Earth still looking like a half-baked pizza that got dropped face down into a volcano. The crust is doing its best to exist, bless it, but it's basically a wobbling sheet of scorched rock floating on a sea of magma tantrums. Think of it as the planetary equivalent of someone trying to put on pants while standing on a treadmill that's also on fire. Meanwhile, the atmosphere is still a hot mess. Literally, you've got steam, carbon dioxide, sulfur, and the lingering scent of planetary trauma. It's the kind of air that would strip the enamel off your teeth before you finished exhaling. There's no oxygen yet, none, zip, not even the slightest whiff of it. If you were somehow time-warped here, you'd suffocate before you had time to scream, "What the hell is this place?" Which is maybe a mercy. But don't worry, Earth's just getting started with its self-destructive creativity. Volcanoes are still popping off like insecure influencers, loud, constant, and leaving behind emotional scars in the form of lava plains. And the impacts? Oh yeah, they're still happening. We're still in the tail end of the late heavy bombardment, which sounds like a death metal band, but was actually just billions of rocks from space saying surprise and slamming into the surface at ridiculous speeds. Now picture this, the crust, fragile as a toddler's ego, trying to stay cool and solid while also being punched from orbit by molten asteroids the size of cities. Every time it starts to heel over, boom, some rogue comet swings in like a drunk uncle at a wedding and ruins everything. The result is a constantly reset surface. Whatever tried to solidify just melts again, because apparently stability is not in the planetary vocabulary yet. Still, Earth is tenacious. Somewhere in this chaotic bake-off, lava-laced mess of convection currents that are already setting up tectonic drama for later. Yes, Earth was petty before it was even habitable. The oceans are doing better, relatively speaking. They've grown deeper, spreading out across the battered surface and pooling into the low points between crustal war zones. They are rich in metals, acidic as hell, and probably bubbling with volcanic gases like a hellish spa bath. You know, the kind of place that screams, ideal conditions for life, if you're a molecule with ambition and no self-preservation instinct. And deep beneath those angry waves, something incredible starts happening. No, not life. We're still in the chemistry with a drinking problem phase, but complex molecules, organic ones, are forming. Amino acids, lipids, nucleotides, the building blocks of all the terrible decisions to come. These aren't alive yet, but they're flirting with the idea, like the first awkward texts before a disastrous situationship. Also, hydrothermal vents, yeah, those have shown up. Underwater volcanoes, belching mineral-rich fluids into the ocean at boiling temperatures. They are essentially the planet's earliest attempt at plumbing, and they create weird little niches where all kinds of chemical reactions are popping off. Some theories even suggest life may have started here, but not today. Today, it's just a steamy metal bath full of bubbles, sulfur, and dashed hopes. The moon, by the way, is still looming, same orbit, slowly drifting away at about 1.5 inches per year, like an ex who wants distance but still insists on showing up in your dreams. But its presence is doing something critical. It's creating tides. Weak ones, sure, because the oceans are still shallow and angry, but tides nonetheless. That slow, rhythmic sloshing is mixing things up in the oceanic soup, giving molecules a little push here, a little nudge there. Kind of like cosmic matchmaking, if all the contestants were single atoms trying to bond. And thanks to all this volcanic activity, carbon dioxide is being spewed into the atmosphere like it's going out of style. This creates a greenhouse effect, which keeps the planet from freezing solid. Because yes, the sun back then was a scrawny little dude, only about 70% as bright as it is today. Without greenhouse gases, Earth would have turned into an icy marble, and this show would have been called Planet Dead. But no, thanks to some good old-fashioned carbon pollution, we stayed just warm enough to keep boiling water on the stove. So, to recap, Earth is crusty, moody, gassy, and barely stable. But it's cooled down enough that surface rock isn't melting constantly. Oceans are real now, tides are starting to move things around, and complex molecules are doing test runs for life. The stage is being set, but the actors are still in the dressing room arguing about who gets top billing. Still, for a planet that started out as a cloud of suicidal dust particles, we're doing okay. And by okay, I mean everything is still awful, but in a slightly more interesting way. Now we're really getting into the messy middle. Earth isn't just an unstable toddler anymore. It's a moody preteen with some bad skin and a habit of breaking its own toys. The crust? Still paper thin in places, and constantly being remelted. The oceans? Murky, acidic, and vaguely pissed off. Honestly, Earth at this stage is like a soup someone left on the stove too long, but is still insisting is edible. But hey, progress is progress. The outer shell is slowly getting more solid, which is great news for future continents and terrible news for whatever dreams you had about a peaceful, spa-like ancient Earth. Spoiler, there's still nothing remotely peaceful about any of this. Deep underground, Earth's core is officially stratifying. You've got a solid inner core, molten outer core, and the beginnings of a magnetic field. Arca, the planet's first line of defense against space trying to murder it with solar wind. It's a little wobbly, sure, but it's there. Think of it like Earth's first really bad haircut, not stylish, but functional. This magnetic field is a big deal. Before it, the sun was just slamming Earth with charged particles like a frat bro with something to prove. Now, some of those particles get deflected, which means fewer molecules are stripped away from the atmosphere, and Earth doesn't end up looking like Mars, at least, not yet. This was the planet's first glow-up, and even though it's invisible, it matters. Up on the surface, tectonic plates are probably starting to do something. They're not moving much yet, but there's enough convection happening below the crust that big chunks of rock are colliding, cracking, and occasionally giving birth to what could loosely be described as early proto-continents. Don't picture land as we know it. Think more flaming rubble slowly learning how to float. And what about those hopeful molecules swimming around in the poison broth we call the ocean? They're still not alive, but they are throwing molecular raves in hydrothermal vents, slamming into each other, getting zapped by lightning, and occasionally forming structures that almost, but not quite, qualify as something that might maybe replicate someday, if the conditions are just right, and the chemistry gods aren't feeling too lazy. Meanwhile, volcanic islands are popping up and disappearing like acne on a stressed-out teenager. They form, cool, erupt again, and get swallowed by the sea. These are the first failed attempts at landmass, little piles of rock with dreams of becoming continents, only to get yeeted by tectonic tantrums. They are short-lived, underappreciated, and probably smell like sulfur and bad decisions. Also, water levels are rising. Not because of climate change, that's a few billion years away, but because more water is being released from the interior of the planet through volcanic outgassing. Earth, bless it, is basically farting its way into having oceans, and every time a volcano erupts, it adds a little more steam and gas into the mix. It's gross, it's chaotic, it's effective. And let's not forget about the asteroid stragglers still taking pot shots at the planet. The late heavy bombardment isn't over yet. Some of these impacts are massive enough to boil entire oceans temporarily. Not a great time to be a hopeful little molecule trying to achieve sentience. One space rock and it's back to square one. Still, somehow, the soup keeps bubbling, and the building blocks keep forming. Now remember that magnetic field we talked about? It's starting to help preserve the planet's early atmosphere, even though it still mostly consists of steam, carbon dioxide, methane, ammonia, and a whole lot of nope. There is still zero oxygen. If you tried to breathe the air right now, your lungs would file for divorce and your skin would probably melt off just out of spite. But the important thing is, Earth is starting to stabilize. Not a lot, but enough. The surface is cooling slowly. The bombardments are less frequent. The atmosphere, while toxic, is thick enough to trap heat. The oceans, despite being more acidic than a Reddit thread, are here to stay. And somewhere down there, in the deep sea vents and tidal pools, the first organic molecules are just starting to flirt with the idea of replicating. They're still not life, not even close, but they're thinking about it. They've got potential. They're like that kid in high school who got straight B's, smelled like nachos, and 20 years later became a startup billionaire. You wouldn't bet on it, but you wouldn't be shocked either. And Earth is finally starting to act like it wants to host something besides explosions. It's like the planet looked at itself in the mirror and said, okay, maybe I don't have to be just a flaming space rock forever. Maybe I can grow, maybe I can change. Don't get too excited though. It's still going to be another billion years of chaotic nonsense before anything remotely interesting crawls out of the ocean and decides to regret everything. But this is the setup. The slow grind. The cosmic simmer. Because sometimes the best things take a few billion years to ruin themselves. So Earth, now with its crusty makeover and moody magnetic field, is officially trying out a new personality, marginally less lethal. Don't get it twisted, it's still a volatile sphere of rage, but now it's trying to vibe. The tantrums are slowing down, the asteroid beatdowns are tapering off, and for the first time in its violent little existence, Earth is starting to, I don't know, chill? Not completely. We're not in hammock and pina colada territory here. More like still screaming, but not every 5 seconds. The oceans are expanding, slowly. Steam from the gassy atmosphere is cooling and condensing into actual water that isn't immediately evaporating in a hiss of betrayal. The surface is hot enough to make soup boil, but somehow water's hanging on. It's pooling in basins and lowlands, forming what could technically be called seas, if your definition includes phrases like mildly corrosive and pre-life fishless death puddle. And speaking of death puddles, those hydrothermal vents at the bottom of the ocean, still cooking. Like the planet's own slow cooker, bubbling out minerals, gases, and just enough weird chemistry to make the molecules go, what if we stuck together? These early molecular experimenters are not alive. They're just very enthusiastic about forming chains and rings and squiggly nonsense that may one day be called RNA precursors, if they're lucky. Let's be honest, it's a mess. You've got lightning, UV radiation, thermal vents, pressure differentials, and tectonic microdances all happening at once. It's like Earth is running a bizarre chemistry-themed escape room, and the prize for getting out is accidental life. Meanwhile, the crust is doing its best to keep it together. Still thin, still fragile, still occasionally cracking under the pressure. Literally. These are the days of proto-continents. Not actual continents, but more like the rough drafts. They rise, cool, and get shattered by the next planetary sneeze. Repeat ad nauseum. Silicate rocks are slowly becoming the new normal. The Earth is busy pulling heavy stuff, like iron and nickel, down into its core, while pushing lighter stuff like silicon, aluminum, and sodium up toward the crust. This differentiation is why we don't live on an iron beach or eat aluminum pancakes. Thanks, gravity. Really pulling your weight. In the sky, The moon is still lurking. After its big, dramatic entrance, it hasn't left Earth's side. It's slowly drifting away, like that friend who crashes on your couch after a breakup and then overstays their welcome for, say, 4 billion years. But its presence matters. The moon is stabilizing Earth's axial tilt, which means the seasons are less psychotic than they could be. And the tides? Oh yeah, they're getting yanked around like marionettes by this smug orbiting rock. It's a codependent relationship, and it's going to last forever. But wait, let's not forget the atmosphere. Still no oxygen, still not breathable. Still just a miasma of carbon dioxide, water vapor, methane, ammonia, and vibes. Occasionally, it gets stirred up by volcanic eruptions or meteor impacts, because this planet is basically a shaken soda can with boundary issues. But it's thick enough to hold in heat, which means surface temperatures are beginning to fall into the "you might survive for 3 seconds" range. And that matters. Because now, in these murky oceans and shady tidal pools, something new is happening. The molecules, the poor, exhausted molecules, are not just colliding anymore. They're reacting. They're folding, sticking, looping, copying bits of themselves in sloppy, desperate acts of molecular narcissism. It's still not life, but it's adjacent, like really close. Pre-life, proto-life, life's awkward younger cousin who's still figuring out how shoes work. It's all happening at the bottom, no sunlight needed, just heat, minerals and time, loads of time. And this messy biochemical party will keep going for hundreds of millions of years before anything sticks. But this is the scene. This is the primordial rave, where life might someday pop out of the haze with a guilty look and say, "Oops, I exist now." At this point, Earth is like a tired rave-goer who's crashed into a beanbag and started mumbling something vaguely philosophical. The chaos is still there, don't get me wrong, but it's settled into a kind of cosmic background noise, volcanic eruptions, meteor showers, tectonic fidgeting, all still happening, but less like a tantrum and more like a constant low-grade meltdown. A simmer, if you will. Down in the depths, the hydrothermal vents are still doing their thing. These underwater chimneys spew superheated, mineral-rich water into the ocean, like they're trying to win some kind of abstract art competition. They're hot, they're toxic, and they're absolutely vital, because this is the prequel to biology. You're not going to find dolphins or plankton yet. What you've got is soup. Not even alphabet soup, more like single-letter soup. Molecules are bumping into each other, doing shots of sulfur, and trying to figure out what it means to self-replicate. It's here, at these underwater vents, that we begin to see something that might, someday, call itself life. Chemical compounds are getting fancy. Amino acids are showing up. Lipids are forming bubbles. Bubbles. You know, nature's favorite container. These tiny lipid bubbles trap molecules inside them, and suddenly, bam! Something vaguely cell-shaped is floating in the water like it owns the place. Spoiler alert, it does not. Now, keep in mind, none of this is happening quickly. We're talking tens of millions of years of chemical flirtation before anything gets remotely organized. And even then, it's not a eureka moment. It's more like, this one didn't dissolve immediately. Let's go with that. Meanwhile, the surface of Earth is still extremely do not touch. The continents, if you can call them that, are stubby, unstable, and constantly getting dunked back into the mantle. These proto-continents are basically the Earth's way of testing ideas like a very indecisive interior designer. Granite? Too heavy. Basalt? Maybe. Plate tectonics? Not quite there yet. but the seeds are being planted. The crust is thickening. It's cooling. It's cracking like a teenager's voice, awkward and unreliable. And below it, magma's still sloshing around like lather punch at a poorly supervised high school party. Occasionally, parts of the crust break off and sink back into the mantle, reheating and recycling like some kind of geologic lasagna. And that's fine, because Earth doesn't need stability. Earth needs drama. In the sky, the moon is still doing moon things, orbiting, influencing tides, looking smug. Its gravitational pull is slowly slowing down Earth's rotation. Back when we started this mess, Earth days were like 6 hours long, just a quick spin and done. Now, we're inching toward a luxurious 12-hour day. What a treat. More time for boiling oceans, acid rain, and quietly assembling nucleotide chains. And the atmosphere? Still a no-go for breathing. Mostly carbon dioxide, methane, ammonia, water vapor, and a dash of hydrogen sulfide. Basically a chemical weapon with clouds. Occasionally, solar radiation punches through and fries the top layer of the ocean, which is fine, because there's nothing up there but disappointed molecules. The real action's still happening deep below, where the sunlight doesn't reach, and no one's judging your molecular decisions. But let's talk about RNA, because this is when it might, just might, be starting to show up. Ribozymes, self-replicating RNA strands, are experimenting with the idea of information storage and chemical reactions. It's like the molecules are starting to write their own operating system, one buggy line of code at a time. It's not efficient, it's not smart, but it's persistent. And persistence, it turns out, is a killer feature. Somewhere in a tide pool or vent or shallow mudflat, a chain of molecules does something useful and doesn't immediately fall apart. And that's groundbreaking. That's a flex. That's the difference between a random chemistry set and the opening act of biology. Of course, there's still no DNA, no proteins, no organelles, no cells with names, just chemical chaos, slowly being shaped by trial, error, and absolute cosmic indifference. And yet, even here, even now, you can see the glimmer of something unstoppable. Life isn't here yet, but it's circling the drain. The crust is mostly solid, but not in a you can build a house on it way. More like, congratulations, it hasn't collapsed in 10 minutes. The oceans are sloshing around, looking murky and toxic, like someone spilled a vat of expired kombucha into a hot tub. And beneath all that steaming acidic nonsense, molecules. Billions of them. Colliding. Merging. Failing. Trying again. It's like a startup incubator. Except instead of burning VC cash, they're burning actual heat from the planet's interior and whatever radiation the sun's flinging their way. Still no DNA, still no cell membranes you'd write home about. But RNA is starting to feel itself. It's forming, folding, breaking, and, every now and then, replicating. Badly. But hey, even a typo-filled essay gets an A for effort when no one else turned anything in. At this stage, We don't have life so much as we have proto-life, which is science speak for we think something interesting is happening, but it's way too early to put a label on it. Lipid bubbles continue to form spontaneously, trapping random junk inside like nature's version of a loot box. Most of these just dissolve or pop like they're allergic to success, but every once in a while one manages to keep it together long enough to do something. Maybe a basic chemical reaction. Maybe a copy of an RNA strand. Maybe just float around pretending it's important. Honestly, that's half of modern life anyway. Meanwhile, the atmosphere is still basically a chemical war crime. The sky is a weird, orangey haze, thick with carbon dioxide and methane. And there's absolutely no ozone layer. So if any molecule decides to venture up top, the sun just obliterates it with UV radiation, like it's swiping left on all life's possibilities. That's why everything interesting is still happening way down in the trenches, literally. Deep-sea hydrothermal vents, volcanic island puddles, warm, shallow pools, Earth's petri dishes of potential. Let's talk about those vents for a second. These bad boys are Earth's original pressure cookers, blasting scalding water and minerals into the sea. They create steep chemical gradients like little energy cliffs, and molecules are tumbling down them, reacting in ways that are sometimes actually productive. It's chemistry's version of falling with style, and when something reacts in a way that helps it stick around longer, that, my friend, is the beginning of natural selection. Except it's not survival of the fittest yet. It's survival of the least terrible. At the same time, the moon is still drifting slowly away, and Earth's rotation continues to slow like a drunk dude trying to lie down without spilling his drink. Days are getting longer. Tides are starting to have rhythm. And if you squint really hard, you can start to imagine something like cycles. Night and day, wet and dry, hot and slightly less hot, all of which are great for chemistry, because nothing inspires change like repetition and stress. Also, Earth's magnetic field is probably starting to stabilize a bit. That's good news for all these fragile molecules, because it means the planet's interior is churning like a lava milkshake, creating a magnetosphere that sort of deflects solar death rays. Okay, so Earth's got its chaotic lava froth phase sort of under control. Under control, in the same way a toddler with a garden hose is technically watering the plants. Still dangerous, still messy, but at least it's not actively detonating itself every other Tuesday. Now we're deep in the Hadean, and Earth is doing its best impression of a moody teenager. Crust cracking, internal heat raging, and absolutely no sign of a stable identity. Most of the surface is this endless volcanic hellscape, peppered with meteor scars and steam-choked basins. Imagine Iceland, but everything's trying to kill you, and the Wi-Fi is just gamma rays. But despite the vibes being aggressively uninhabitable, something wild is starting to happen. The crust, bless its flaky, geologically unstable heart, is thickening in places. Tiny bits of continental crust, made of lightweight felsic minerals, are popping up and hanging around longer than usual. These aren't continents like you'd recognize. More like Earth's first pimples of stability. Gross but formative. And with that crust comes weathering. Actual weathering. Not just volcano go boom, but the slow, stupid miracle of rain hitting rock and breaking it down into minerals that end up in the ocean. It's like Earth accidentally discovered skincare. And those minerals? They're key ingredients in the weird little soup kitchen of early life. Phosphates, silicates, iron. Nothing glamorous, but all essential. Now zoom in. No, further. into the warm, slightly radioactive puddles pooling on the edge of those crusty volcanic scabs. These puddles are not clean. They're riddled with carbon compounds, salts, weird metals, and the occasional dash of ammonia, basically the Gatorade of prebiotic chemistry. Molecules are still bouncing off each other, forming temporary alliances, folding, unfolding, failing. But failure is the name of the game here. 99.9% of all molecular configurations are total trash. They fall apart immediately, or can't replicate, or do nothing except sit there like a chemically confused potato. And yet, somewhere in this molecular mosh pit, self-replicating RNA is stumbling into existence. Not life yet. More like life's weird cousin who can't hold down a job but somehow keeps getting invited to family gatherings. Some of these early molecules can catalyze reactions. Some can copy themselves, but poorly, which ironically is great because errors lead to variation, and variation is basically evolution's entire reason for waking up in the morning. You're getting feedback loops now, chemical ecosystems. The vibe is less random chaos and more incoherent but persistent. Also, tectonics are low-key starting to show up. Nothing dramatic, no plate boundaries yet. But convection currents in Earth's mantle are doing their thing, recycling crust, building pressure, making little magma cookies that rise, cool, and get crunched. It's like a really slow, very dangerous panini press. In the deep sea, the hydrothermal vents are still MVPs. Black smokers and alkaline vents are cranking out mineral-laced fluids at temperatures that scream nope to any modern organism. But back then, perfect conditions for chaos with a chance of biochemistry. Iron-sulfur gradients, chemical disequilibria, and weird electrochemical surfaces, that's catnip for early life. And yeah, maybe, just maybe, you've got some protocells forming. Not alive in the I have a mortgage and emotional trauma sense, but alive in the I can grow, divide, and kind of remember how I did it last time way. Barely organized bags of molecules. But they stick around. That's what matters. Meanwhile, on the surface, Earth is still being bombarded by comets and asteroids every now and then. Not the same apocalyptic blitz from before, but enough to keep things spicy. Some of them bring water, organics, and raw materials. Others just explode and ruin whatever progress the molecules were making that week. It's like trying to do a group project while someone occasionally throws flaming bowling balls at your lap bench. Through all of this, time keeps chugging forward. 80 million years of chemical patience. No applause. No audience. Just raw persistence. And if you're wondering why this matters, why we're bothering to talk about these soggy, microscopic, not quite organisms, it's because this is where the weird magic happens. Not in the dramatic lava flows or planetary smash collisions, in the quiet, murky, slimy places, where life didn't appear so much as it refused to stop trying to happen. And that's kind of Earth's whole personality. Let's keep hovering over this wonderfully gross chapter of Earth's origin story. The one where nothing is alive yet, but everything is thinking about it. We're still pre-cellular life here. Everything's mushy and unstable, like a half-baked science fair volcano made by a kid who only read the first page of the instructions. But chemistry is getting ambitious. Those prebiotic puddles we talked about, they're not just simmering anymore. They're steeping, marinating, fermenting in ultraviolet radiation, volcanic minerals, and just enough cosmic spice to keep things interesting. And in those puddles, chains of molecules are starting to do weirdly structured things. Lipids are spontaneously forming membranes, because apparently even molecules have boundaries now. These membranes trap other molecules inside. Sometimes that's bad. Mostly it's boring. But sometimes, rarely, it leads to something resembling a protocell. Imagine a soap bubble that doesn't immediately pop, filled with RNA that's trying really hard to cosplay as a life form. That's the level we're at. Meanwhile, deep in the ocean, the vents are still out here being chaos factories. These are not serene hot tubs. They're blasting out sulfides and metals at temperatures that scream immediate regret. But they create gradients, those lovely little chemical imbalances that make everything possible. Protons go one way, electrons another, and in the middle, molecules are getting pushed into configurations they'd never manage in calm water. Some scientists think life may have actually started right there, at these hydrothermal vents, in tiny mineral pores acting like nature's version of a startup incubator. The first lucky strands of replicating molecules, they might have been born in a calcium silicate rock crevice next to a stream of boiling hydrogen gas. Sexy, right? Meanwhile, on the surface, Earth is still a crusty mess. The atmosphere, if you can even call it that, is a thick cloud of volcanic vomit. Carbon dioxide, methane, hydrogen sulfide, basically a death fog. You couldn't breathe it, you couldn't see through it. But for pre-life chemistry, it's a buffet. Lightning still crashes through the haze, and every strike is like nature rolling the dice. Sometimes it's just noise. Sometimes it's enough energy to fuse molecules in new ways. Some of those become useless garbage, others stick around. Again, it's persistence over perfection. Evolution doesn't need things to be good, it just needs them to not immediately die. And Earth's magnetic field? That's starting to stabilize, kind of. Enough to fend off some of the solar wind, which is nice, because otherwise the sun would just strip away every gas molecule and leave Earth looking like the moon's dry, sad cousin. Thanks, magnetosphere. You're doing amazing, sweetie. The moon, by the way, is still awkwardly adjusting to its role. It's closer than it'll ever be again, so close that if you looked up, assuming your eyes weren't boiling from acid mist, you'd see a terrifyingly large sky rock dragging tides across the molten oceans. It's not just pulling water either, it's tugging at Earth's crust, stirring the mantle, creating a tidal friction massage that's heating up the interior. You know, for fun. And time is crawling. You're looking at 80 million years of this weird soup phase. That's a whole Netflix series of absolutely nothing happening to the naked eye, but molecular drama on par with a reality show reunion episode. Molecules meet, they fight, they break up. One of them tries something new, and suddenly everyone's copying it. Occasionally, a meteor slams in and wipes the local chemistry back to zero. It's a harsh neighborhood. But chemistry doesn't quit, not because it's smart, because it's there. That's the thing about this stage. There's no blueprint, no destiny, no divine plan. Just trillions of dumb little reactions happening over and over, hoping to accidentally invent complexity. And somehow, over this geological crawl space of time, the ingredients for life are not just forming, they're learning to cheat entropy. Very slowly, very stupidly, but with vibes. All right, we're finally dipping a toe into the first whispers of the Archean eon. Don't get excited. It's still mostly rock-flavored nothing. But the vibes are starting to shimmer. Let's begin with the sky. It's still a choking soup of volcanic gases and photochemical chaos. You'd cough just thinking about it. If you had lungs, which you don't, because life hasn't technically kicked off yet. The air is thick with methane and ammonia, layered under a curtain of carbon dioxide and water vapor. Every sunrise is an ultraviolet bloodbath. The clouds are brown. The rain is acidic. The whole atmosphere is like Earth's angry puberty. loud, unstable, and occasionally explosive. And yet, it's home. Down below, the surface is finally starting to look a little less like Satan's grill. The crust has cooled into massive slabs. Proto-continents, though they're more like oversized rocky floaties in a global jacuzzi. The oceans are still dark and warm, full of minerals and metals and heat. No blue tropical waves yet, more like a planetary soup that's been left in the sun for 3 billion years. But it's getting interesting. These early oceans are swarming, not with life, but with organic molecules bumping into each other like drunk strangers at a house party. Some of them get clingy, some dissolve immediately. But once in a while, the combinations stick. Long carbon chains, fatty acids, amino acid precursors, RNA-like fragments that don't know they're about to become important. It's molecular speed dating, and nobody has any standards. And somewhere in this sludgy mess, something happens that matters. A few chemical chains figure out how to copy themselves. Not well, not reliably, but enough to say, hey, I'm a thing, and now there are two of me. And that's treason against the second law of thermodynamics. That's the first flicker of something that doesn't just exist, but persists. Replication is here. Kinda. Let's not oversell it. This isn't a cell, or a creature, or even a solid idea. It's like if someone accidentally invented TikTok in a cave without realizing it would someday eat the brains of millions. The first replicators aren't smart, or strong, or even consistent, but they make copies, and those copies make copies, and occasionally they screw up just enough to evolve. And boom, you've got the first ever popularity contest in chemical form. Meanwhile, tectonic activity is extra spicy. Earth doesn't have a proper plate system yet, but the crust is restless. Hot plumes from the mantle rise like molten lava pimples, breaking apart rock and rearranging it in slow-motion tantrums. Oceanic ridges form and vanish. Islands boil up and sink again. It's like a game of geological whack-a-mole, and nobody's keeping score. The moon, still lurking overhead, but it's slowly ghosting away. Thanks to tidal interactions, it's receding at a rate of about 4 centimeters per year. Not fast enough to matter to anyone, but it does mean the days are getting longer. Back then, an Earth day was about 14 hours long, still faster than your average TikTok attention span. But hey, we're stretching. The magnetic field continues to strengthen, shielding the surface from the sun's radioactive tantrums. Not perfectly, but better than nothing. Without it, every molecule trying to form anything complex would be instantly fried by solar wind. So thanks again, Earth's molten nickel core, you mysterious swirling hellball. Oh, and remember the meteor problem? Still a problem. Earth gets regularly clocked by space debris, some of which is big enough to boil oceans and sterilize continents. But, silver lining, it also delivers some crucial ingredients: carbon, nitrogen, and possibly even water. You know, just tossed in like seasoning by the universe's least careful chef. All this to say, the stage is almost set. Not for life, but for something that might someday squint in the direction of being alive. We're talking about lipid membranes forming around RNA-like chains, protected by mineral shells or oily blobs, getting just enough energy to divide before collapsing again. It's chemistry pretending to be biology, and it's doing it more and more often. Somewhere in these endless trials, the first proto cells might be squishing into existence. Not alive, not sentient, but annoying enough to leave a mark in the geologic record. Of course, we won't see actual life for a while. Like a long while. So for now, sip your primordial tea and appreciate the absurd patience of a planet that spends 80 million years just mixing ingredients. Okay, so here we are watching Earth awkwardly fumble its way through molecular puberty like a rock with dreams. 80 million years is basically one long exhale for a planet. But things are, well, less boring now. You might even say there's a vibe shift. Let's start beneath the surface. The mantle is still throwing tantrums, churning hot plumes upward like it's trying to punch through the crust just to see what happens. Subduction isn't quite a thing yet, too early, but blobs of crust are being recycled, melted, and reborn. It's like the Earth is experimenting with continental plastic surgery and hasn't settled on a look. On the surface, the continents, or proto-continents really, are starting to stick around longer. These aren't your familiar landmasses, they're patchy, volcanic pancakes bobbing in the middle of steaming oceans, barely solid and constantly being slapped around by tectonic chaos. But still, they exist, and that's enough to make the planet feel slightly less like a molten death orb and more like a geologically unstable mud pie. The oceans, still steamy and opaque, are rich with dissolved metals and other spicy ingredients. They're full of energy gradients, chemical fluxes and hot vents that would make a microwave jealous. If there's anywhere life could start screwing around, it's here, in the weird, wet, mineral-rich darkness at the bottom of the sea. Now let's talk about hydrothermal vents. These things are like the nightclubs of early Earth, super hot, incredibly toxic, and full of questionable life choices. Deep under the ocean, cracks in the seafloor let seawater seep in, get heated by magma, and come blasting back out loaded with hydrogen, sulfides, and other goodies. These black smokers are basically nature's fondue fountains for chemistry nerds. And at the bottom of these vents, tiny pockets of order. Gradients that allow molecules to do interesting things like cling to rock surfaces, grab energy, and maybe, just maybe, start replicating in a way that matters. Scientists think this might be where life first sparked. Not life like a jellyfish or a blade of grass, but more like a greasy bubble wrapped around a semi-functional molecule that refuses to die. It's the biological equivalent of a Craigslist ad that just says, "Still here." These early replicators are borderline tragic. They don't metabolize. They don't have DNA. They barely hold themselves together, but some manage to surround themselves with oily membranes. Others trap useful ions. A few learn how to sponge off the gradients around hydrothermal vents like little chemical freeloaders. And eventually, a handful become just stable enough to stick around. And once something sticks around, evolution gets to work. Slowly, painfully, randomly. It's not intelligent. It's not aiming for anything. It's just a relentless algorithm that rewards slightly less terrible with survives another day. Meanwhile, the sky is still a no-go. There's no ozone yet. UV radiation from the sun hits the surface like an overclocked death laser. Anything that tries to exist near the surface gets fried faster than your last brain cell during finals week. Which is why these little chemical blobs hide deep underwater, tucked away in the comforting hellscape of the ocean floor. Above the water, continents continue their slow-motion dance. Volcanic islands rise and sink. Continental fragments split and rejoin like drunk puzzle pieces. The crust thickens, just a little. Weathering starts to matter. Rain, still acidic by the way, carries minerals from land to sea, adding more weirdness to the ocean's chemical soup. The planet is stirring its own cauldron of potential. Let's not pretend any of this looks impressive. If you time-traveled here, you wouldn't be able to breathe. You'd be boiled, irradiated, and crushed before you could even ask, "Where's the beach?" But to Earth, this is progress. This is evolution's soft launch. And get this, some rocks from this time period, found in places like Greenland and Australia, show isotopic hints that something weird was happening. Ratios of carbon and sulfur that don't match pure geology. Structures that look suspiciously like microbial mats. It's not a smoking gun, but it's definitely a warm, squishy trail of evidence that life might already be whispering into the rocks. So we're not saying life is definitely here, but we're not saying it isn't either. It's Schrödinger's organism, maybe alive, maybe not, but making just enough noise to keep us arguing about it 4 billion years later. And that, honestly, is peak early Earth energy. Chaotic, underwhelming, and just barely clinging to potential. Alright, so we're still swimming around in this lukewarm primordial soup, which at this point smells vaguely like a nickel-plated armpit. The Earth, bless its molten heart, is out here doing its best impression of a haunted crock pot, bubbling, belching, and quietly assembling ingredients for life with the patience of a caffeinated toddler stacking Legos. Let's talk about the crust for a second. Not the kind you scrape off a pizza box, the kind that's floating on a bed of molten rock and occasionally exploding without warning. The continental crust is thickening ever so slightly, like a really bad batch of pancake batter left too long on a hot griddle. It's more stable than before, still volatile, but it now has the confidence to say, I'm not that explosive anymore, and only burst into flames twice a week. These proto-continents aren't continents in the way you know them. They're stubby, misshapen land blobs, drifting like confused ice cubes in a simmering stew of magma and misery. They don't have names, they don't have borders, they just float. Occasionally, they smash into each other and then pretend it never happened, like two drunk exes at a bar. Meanwhile, the oceans, still toxic, still hot, still full of metal ions and potential. There's a sort of chemical carnival happening down there. Ammonia, methane, hydrogen sulfide, and enough trace metals to kickstart a cyberpunk dystopia. The hydrothermal vents, still raging with the intensity of a 2007 dubstep drop, are pumping all sorts of goodies into the depths. It's the kind of place where life doesn't just begin, it has to improvise. And life might have just done that. Sort of. Somewhere near those angry black smoke events, greasy proto-life forms are throwing molecular tantrums. RNA-like chains are forming, folding, breaking apart, and trying again. Most fail. Most dissolve into the background like unpaid interns. But a few start to stick. Not like, hey, here's a cell. More like, here's a molecule that won't shut up and keeps making copies of itself, even though nobody asked it to. Welcome to pre-life's version of social climbing. Replication. Imperfect, glitchy, annoying replication. These molecules aren't exactly smart, but they're persistent. And sometimes, persistence is all evolution needs. Now, do we have fossils from this exact moment? Absolutely not. This is Earth's burner-phone era. No receipts, no records, just chemical chaos and plausible deniability. But we do have ancient zircons and isotopic clues that suggest the crust and oceans were stable enough to host life. Like the planet had stopped screaming for 5 minutes, and something heard the silence and whispered, "Now?" In Australia, there are rocks dating back to this period, specifically the Jack Hills zircon deposits, that contain minerals hinting at the presence of liquid water and surface weathering. These aren't fossils, but they're basically geological gossip, little hints that Earth might have been habitable-ish earlier than we thought. Speaking of habitability, let's not forget the sun was a bit of a jerk back then. Faint, yes, but still flinging UV radiation around like a toddler with a loaded paintball gun. There's no oxygen, no ozone layer. Nothing stopping that sweet, sweet cosmic death beam from reaching the surface. That's why life, if it existed, wasn't hanging out on land or even near the surface. It was hunkered down in the deep, dark ocean trenches, like an anxious introvert at a rave. Also, Earth's magnetic field, barely there. It's developing thanks to the planet's spinning iron core, but it's more of a polite suggestion than a real shield, which means more radiation, which means more molecules mutating in weird, sometimes useful ways. And weirdly, that helps. Radiation, while absolutely awful for any organism trying to live, is great at pushing evolution to try new things. Like, what if I folded this protein differently? Or, what if I surrounded myself with a slightly thicker membrane? It's trial and error, mostly error, but the trials that work get to exist for a few more minutes. Congratulations, you've invented progress. Meanwhile, tectonic activity is picking up steam. Subduction might actually be starting here. Just the tiniest hint of plate tectonics whispering, hey, what if we made mountain ranges and recycled the crust forever? It's not confirmed, but some ancient rocks show signs of early plate-like behavior, which is Earth's way of practicing for its future career in continental drama. So what do we have? A crust that's pretending to be stable, oceans that are one bad mood swing away from boiling over, vents spewing hot, toxic soup, and molecules trying to invent life like they're cramming for a group project they forgot was due 4 billion years later. It's not much, but it's a start. Okay, so we're still stewing in the great cosmic crockpot, and Earth is doing what it does best, being barely functional but somehow still chugging along. We're now somewhere in the neighborhood of 3.7 billion years ago. Don't worry, you didn't miss much, unless you count almost maybe probably life as exciting, which it is, but not in the way you'd think. There's no let there be life moment, just a slow, slimy cough into existence. Let's talk about the Isua Greenstone Belt in Greenland. These rocks are older than your grandpa's sarcasm and might, just might, contain some of the earliest indirect evidence of life. Not fossils, we're not there yet, but isotopic ratios of carbon in these ancient rocks suggest that something living, or at least formerly living-ish, might have left its chemical fingerprints behind. It's the biological equivalent of a weird smell in the fridge. You're not sure what it is, but it's definitely something. Meanwhile, the planet itself is still acting like it's on a roller coaster built by a sleep-deprived raccoon. Volcanic activity? Relentless. Earthquakes? Constant. Crust stability? A rumor. Every square inch of the surface is essentially a rage-filled geology experiment. And the oceans, our toxic hot tubs of mystery, are sloshing around, full of dissolved minerals and chemicals that would make your liver tap out just from looking at them. But those chemicals? They're doing something miraculous. Slowly, molecular chains are getting longer. They're folding in semi-useful ways. The ones that fold wrong dissolve. The ones that fold right replicate. Not well, not fast, but enough to start forming the biochemical equivalent of social cliques. Primitive membranes form. Some blobs are better than others at keeping their crap together. Those blobs stick around. The rest, deleted by nature's unforgiving try again button. What we're seeing here is the beginning of selective advantage, not evolution in the way you'd recognize it. Not yet, but a kind of molecular rat race. Some molecular setups are just slightly better at surviving in this caustic soup. And Earth, being the little sadist that it is, keeps turning up the heat just to see who flinches. And the sun? Still a jerk. No ozone, remember? So ultraviolet radiation is blasting the surface like a spotlight on a thief. That's why most of this biochemical drama is happening underwater or underground, in cozy pockets near hydrothermal vents. These little crevices become cradles of chaotic invention, life's sketchy garage lab, where nothing is safe and everything is flammable. Down here in the abyss, It's less Garden of Eden and more dumpster behind a chemical plant. But guess what? It works, somehow. Molecules start to form basic metabolic cycles. Like, hey, if I absorb this molecule and excrete that one, I don't die. Barely. Life is basically a chemistry student scraping by on caffeine and stubbornness. We don't know exactly what these life forms looked like, if they even deserve to be called forms. Think more greasy blobs of carbon, hydrogen, and desperation. They probably didn't even have DNA yet. Just RNA-like chains bossing each other around, pretending they're in charge. Cell walls were more like loose suggestions than solid boundaries. Everything leaked, everything broke, and somehow, some of it survived. Also around this time, a big geochemical shift might be happening. The first true chemical signatures of biological carbon fixation. That's science speak for something alive-ish is maybe turning CO2 into something slightly less useless. These hints are found in the form of carbon-12 to carbon-13 ratios that don't happen unless life, or something pretending really hard, is involved. Again, no smoking gun, just a suspicious trail of circumstantial evidence and a vibe that something wild is starting to brew.
Meanwhile, the atmosphere is still an unbreathable mess of volcanic exhale.
Nitrogen, carbon dioxide, water vapor, hydrogen sulfide, ammonia. Basically a cocktail that would kill you before you finished inhaling. There's no blue sky, no breathable air, no birds, just clouds of doom. And the occasional lightning strike to stir things up like an angry bartender with a grudge. And tectonic plates, still kind of fake. They're flirting with the idea of full-blown plate tectonics, but it's more like a messy on-again, off-again situationship. Some subduction might be happening. Some crust might be recycling. But it's early, and everything is still super janky. This is Earth's beta phase, and the bugs haven't been patched yet. Despite all this, the groundwork for something incredible is being laid. Very, very slowly. You've got energy gradients. You've got a chemically reactive environment. You've got structural molecules being nudged by physics and chance toward greater complexity. It's like watching a Rube Goldberg machine try to make a sandwich, except it's made of mud and plasma and has no idea what a sandwich is. But life? Real life? It's so close you can almost hear the slurp of its first accidental breath. All right, so now we're easing into the 3.6 billion year mark, give or take a few million, which in Earth terms is like shrugging off a few centuries. But here's the vibe. Earth is still basically one giant anxiety attack wrapped in lava and ocean mist. And somehow, in this mess, life isn't just maybe happening. It's digging in. Let's be honest, nobody sent out invitations for life to arrive. There were no trumpets, no glow-ups, no "we made it" Instagram stories. Just a stew of unstable molecules occasionally bumping into each other in a warm, wet void. But now? Now there are signs, actual geochemical receipts, of life starting to leave little smudges in the fossil record. Not fossils like, say, bones or trilobites or anything with, bones, but weird little chemical traces in ancient rocks that scream, something was definitely trying not to die here. Take the Barberton Greenstone Belt in South Africa. These rocks are ancient, like should be in a nursing home ancient, and inside them are tiny graphite inclusions that, based on their carbon isotope ratios, might have been left behind by some primitive, carbon-fixing life forms. Still no proof of who or what they were, but it's like walking into a room and smelling pizza. You didn't see it, but you know someone was there. So let's talk about what these little pioneers were probably like. Think microbial mats, flat, sticky communities of prokaryotes that band together for warmth, safety, and passive-aggressive molecular gossip. They're hanging out in the shallow parts of Earth's toxic oceans, clinging to rocks near hydrothermal vents or sunlight-lit puddles, where they can photosynthesize without immediately dying. And yes, that means some of them are starting to dabble in the dark arts of photosynthesis, the biggest flex since not being dead. Now don't get too excited. This isn't the good kind of photosynthesis, the kind that eventually floods the world with oxygen and makes animals possible. Nope. This is the janky version, the kind that uses hydrogen sulfide instead of water, which, instead of releasing sweet, breathable oxygen, farts out sulfur. It's basically rotten egg photosynthesis, and it smells as good as it sounds. But it works, sort of. These early microbes, likely an archaic gang of anaerobic troublemakers, are managing to convert energy from sunlight into food, which is a wild leap from just absorbing whatever chemicals happen to float by. They're evolving slowly, but every now and then, some freak molecule figures out a better way to do things and boom, it gets copied. Not because it's smart, but because evolution is petty like that. Meanwhile, tectonic activity is starting to pretend like it knows what it's doing. Bits of continental crust are forming and stabilizing just enough to stop melting immediately. You can thank the zircon crystals for helping us figure this out, by the way. Tiny, sparkly time capsules found in Western Australia that date back to around 4.4 billion years ago, but now they're embedded in crust that's not trying to kill itself every 5 minutes. Progress. These early continents, if you can even call them that, are more like floating rafts of less dense rock trying to not sink under the weight of volcanic trauma. But they're important because they become the real estate where shallow seas can accumulate. And those shallow seas? That's prime microbial turf, like beachfront property for slime. It's also worth noting, the Earth is still not a stable environment at all. Between asteroid impacts, mega-volcanic burps, and occasional planetary burlesque acts from the moon tugging on the tides like a drunk ex, nothing sticks around for long. But life loves chaos. It's thriving on the edge, because in stability, nothing changes. But here, in this mess, everything mutates. And let's not forget, life is still tiny, like unimaginably tiny. If you somehow got dropped into this era and looked around with your naked eye, you'd see nothing, just bubbling mud, steaming water, and rocks. But on a microscopic level, it's a rave. RNA chains wiggling, lipid membranes jiggling, molecular machinery cranking out proteins like overworked interns. You wouldn't know it, but the ancestors of everything, trees, whales, that influencer who says literally too much, are here, hiding in the muck. Also, fun side note, around this time, the earliest evidence of stromatolites may be forming. What's a stromatolite? Imagine a pile of microbial poop layered over thousands of years, forming rocky domes in shallow waters. They're like microbial retirement communities, slowly building condos out of their own waste. Glamorous, right? But in terms of evolutionary real estate, these are beachfront mansions. They'll dominate the biosphere for over 1 billion years, because, well, nothing else can be bothered to compete. So here we are, 3.6-ish billion years ago, and life is technically a thing now. It's not intelligent. It's not visible. It's not even particularly efficient, but it's stubborn. And stubbornness is the foundation of all great things, especially on a planet that's just barely holding itself together. The takeaway? Earth is no longer just a spinning rock of chaos, it's a spinning rock of chaos with an attitude. And that attitude, it's starting to evolve. Around this time, the surface of the Earth was finally starting to calm down, which for early Earth just meant fewer planet-sized explosions per week. The crust had thickened slightly, enough to pretend it had its act together. Beneath that, magma still bubbled like a rage-filled smoothie, but now it was at least forming a more permanent surface. even if it cracked and belched like a freshman geologist's worst nightmare. Meanwhile, up top, the oceans, those hot chemical soup bowls, were starting to cover more ground. Rain kept falling in exhausting, endless waves, and the oceans stretched their murky, acidic fingers across the jagged rocks like they owned the place. In a way, they kind of did. At this point, the sea was the only decent real estate on the planet, even if it was constantly boiling and smelled like metal and bad decisions. Deep in those waters, chemical reactions were going wild. Minerals leached from rocks, gases from volcanoes dissolved into the mix, and the oceans became a bubbling cauldron of potential. Not potential like dreams and ambition, more like, hey, what if we accidentally invented life by throwing random atoms together? No one really knows where the first building blocks of life came from. Some say it happened near deep-sea hydrothermal vents, basically underwater hell chimneys that belch out minerals and heat. Others argue it was more of a tide pool thing. Either way, the ingredients were there. The energy was there. The chaos was definitely there. And so, life probably didn't happen yet. Not quite. But the whispers of it were starting. Amino acids were forming. Organic compounds were bumping into each other at parties. Somewhere, something clicked. Not clicked like consciousness, but clicked like let's make a molecule that copies itself. Which, let's be honest, is pretty creepy. But also, kind of a big deal. It's like the universe had been cooking something weird for 80 million years and just now remembered it left the stove on. We're still in the Hadean era, barely edging into the Archean. No atmosphere you'd want to breathe, no solid landmass you'd want a vacation on, and definitely no Wi-Fi. But the stage is being set. The lights are dimming. The opening act of life is shuffling nervously backstage. Earth had gone from molten trash fire to slightly less molten chemical swamp. Still unrecognizable, still dangerous, but a lot more interesting than a floating ball of lava. And so the Earth had settled. Mostly. Kind of. The crust was less like a lava trampoline and more like, well, a crust. Continents? Not really a thing yet, just some scattered proto-islands pretending they knew what they were doing. The sky had cleared up just enough to stop looking like the inside of a barbecue smoker, and the oceans had stopped boiling long enough for chemistry to throw its weird little prebiotic house party. Life, that stubborn, uninvited guest, was starting to stir. Not like squirrels and daisies, more like molecules bumping into each other and thinking, hey, what if we did this again? But we're not there yet. No mitochondria, no single cells, just whispers, just hints. The overture before the weird symphony of biology begins. But we've made it through the first 80 million years of this mess. Congratulations. That was episode 1. And if you're still awake, honestly, you deserve a certificate.